Alright, this is my video 4 for the game engine final sprint. In this video, we'll be taking a look at the Sprite class as well as the gameObject lifecycle, and then just be generally piecing together how all of this comes together inside the tank demo. But first, we're taking a look at the Sprite header file. We see in here in the protected we have a set scale, rotation Z, world matrix, and a transform, and then a graphics object sprite pointer that is the sprite that we'll use to render. And then we have all these public functions that the user can access to manipulate the sprite in various ways. We have the sprite constructor, which will just take the image pointer and a rect pointer, which is used for actually creating the sprite graphics object. Then we have various set functions as well as a couple get to go with it. If we take a look at these inside the CPP, in our constructor we're just creating a new graphics object sprite using the given image and rect that the user had, and then we'll just set the scale, transform, and rotation to default values, and then we'll just update the world based on those values. We have a set image function which the user can call, passing in a new image which they can use to change what image is being used in the sprite. You want to update what it looks like. We have the set origin, which will take in an X and Y value, which are pixel coordinates, with 0, 0 being the top left, and then you can pick where the origin of the sprite will be. We have a set scale by factor where you just take in an X and Y, and we will increase the scale by that factor. This would be the width and this would be the height. And on each of these we're updating the world for the factor. And then get height and get width just return height and width. Pretty easy. Now set scale by pixel, we'll just go in and we'll actually set the width and height inside the matrix with the given width and height values. You want to set particular values by pixel. Set position just takes in an X and Y position, which would be the screen position, and we'll set that in the transform and then update the world. Rotation, we just take in a rotation value that's a float, and then we update our Z rotation since that's the only rotation that matters, and we'll update the world. And that's the update world function, which just encapsulates the world matrix update and the set world. And then we have register draw and registered or deregister draw functions within the sprite, which will work the same way as draw registration and draw deregistration, except we'll go through the 2D path, which will end up in the storage list 2D inside the drawable manager, which will cause these sprites to be drawn last. So if we're looking at that again, we'll end up here in storage list 2D, which will draw after the other drawable objects, ensuring that sprites are drawn last in the scene. Coming back to the sprite, so that is the register draw and deregister draw. That we'll just call draw on the sprite object itself, which then draws to the UI camera from the scene. And then we have the deconstructor, which will just clean up the graphics object if one is currently existing, which it should. And then we just make sure that we're not draw deregistered if we're trying to deregister for draw. Then looking at the game object itself, this has a submit entry and submit exit function, which can be called inside the game object by the user, and those will come back to scene entry and scene exit commands. So if we're looking in here, the user can call submit entry and submit exit. So upon submit entry, we are submitting a command to the scene registration broker for the game object enter, and then the exit is the same thing for the game object exit, which we'll call these gameObject entry and exit commands. We're looking at these. The entry command we'll just call connect to scene. Which we'll then just call connect to scene here. And then connect to scene we'll call scene entry inside the gameObject. And then it's the same thing with submit exit, coming back to disconnect scene, calling scene exit, which these are used for game objects entering and exiting a scene, but they are not being deleted. So this would be something in the case of recycled game objects in a factory. Take a look at something like this. In the user code, we have this factories filter. We can take a look at the enemies. So this is a singleton enemy factory, which has a list of inactive and active items, and a spawn enemy and enemy return, as well as an initialize and terminate. But whenever spawn enemy is called, we will just call, if we have no inactive items, create a new enemy. And then down here, we would push that new enemy into our list of active items. But at the end of this, we're calling initialize on our enemy, but then we are calling submit entry, which is important for the game object coming back into the scene. Since if it was a recycled object, we would need to call this again, where we would do all of our submit registrations for either update, draw, or alarmable, or whatever we need. And then down here in these factories, we're just doing memory cleanup and deleting any active or inactive items that we have spawned. But if we look at something like the enemy, so he has an initialize to set his values whenever he's created, just resetting these things on an individual basis. But then scene entry is called, where we can call collision registration updatable, drawable, and we can submit our alarm for the tank firing. And then, as we saw before in the other video with the collision with the bullet, our B sphere turns red, and if we have no more health, which the health is just set to 1, then we will call enemy death and we will submit exit, which will come back to scene exit, where we report our death to the game manager, and then we deregister for everything that we registered for, and then return this instance to the factory. So it goes into the list of inactive enemies. But then we can check here in the tank. You can see we have the constructor, but in here we have, you might better see it in the header, we have these sprite pointers, which are all our UI sprites. Oops. So we create a new sprite given that image and these recs, and then in here we just call the UI shell register draw so that it is drawn to the screen. And then for the shell, we're setting the origin to the top left corner, and then we have the reticle, the body icon, and the UI turret icon. And then the UI turret icon, the origin is actually being set to the middle of the width, and then the very bottom of the height, which you will see inside the demo. But we can also see when you press spacebar and fire the bullet, we will call UI shell deregister draw, which will call the sprite to no longer draw onto the screen, which then submits this alarm for the cooldown for you to be able to fire again. And when this alarm goes off, we will call UI shell register draw, so you'll see the bullet pop back up indicating you could fire, and then you can shoot and the sprite won't draw again. But then also this whole thing is set up inside the load all resources. We have the scene manager load start level, where we set start scene for a new splash screen, which would start the splash screen. which is the scene here, just containing the splash sprite and a menu controller that's just looking for the enter key input to start the game. And that will start the demo level, which sets the collision pairs for tank, enemy, bullet, bullet, enemy, and calls game start on the game manager with that level, which if we're looking in here at the game start, and here we're just saving what current level is, and we grab the image sprites for the normal enemy tank and the defeated enemy tank, and we set our enemy count to 0, and then we just run a spawn level function based on what level number we got at game start, which are just kind of hard-coded enemy spawns where we will create a new sprite on the screen representing an enemy, and we call that to draw, and then we call an enemy spawn from the enemy factory, and then we so then we create the new sprite. This is actually this is level text saying level 1 at the top of the screen, and then this is the sprites on the side of the screen indicating whether an enemy is alive or dead, and then we increase the enemy count. And then as you saw, anytime an enemy is hit, it will call enemy death, which will come back to this private tank death, where we will change the sprite at that index set image to the dead UI, updating from the red tank to the gray tank, decrease enemy count, and if the enemy count is 0, then we call set our next scene, which depending on what level we are, if the current level is level 1, then we'll start level 2, otherwise we'll return to the splash screen. But if we launch this, we can see this. So we'll load up into the sprite's splash screen, which has all the controls listed at the bottom. The only control that isn't listed is M will return to the splash screen if you ever need to go back. We can start this level. And anytime we shoot and kill an enemy, we'll see the sprite update. But we can also see anytime that I shoot that this sprite will deregister for draw, and then it'll come back. Then we'll load into level 2, which has more enemies. And you can actually see on these enemies that they are updating with player position to have their turrets rotate to follow you, and then they shoot out the barrels. If we kill all these enemies, and then we'll return to the splash screen, and that is my tank demo.